Alright, here are our notes on 6.4 independent variables. This is not in our book, which is why I'm making the video here. So in a certain game, we get the following probability distribution. We don't know if it's geometric, Poisson, binomial, because we don't know anything about the game. We just have the distribution. So we find our probability by using the formula on the formula sheet, which is x times p, and then take the sum of those. Multiply across, add down, and find our standard deviation, same thing. But we can use our calculator. So if we're using a calculator, put in a spreadsheet, we need to make sure we label these. X and P make sense. X for our discrete variable and P for probability. And we go to Menu, Statistics, Stat Calculations, and it's one variable. It's just one list. But when we get here, our X list is X, and our frequency list is our probability. So it's like what we did in Chapter 3. These are always going to be variable references, because that's what we labeled our variables as. And it gives us our mean and standard deviation. Obviously, to get our variance, we have to square that, because it is sigma squared for variance. So we got 1.4, 0.8, and 0.8 squared is 0.64. We can do the same thing on GeoGebra, one variable analysis. Go to data with frequency, click on that, grab your hand it, and analyze. Mean, standard deviation, same thing. And if we want to do a histogram, we have to do it by hand, because GeoGebra does not do it in group data like this. But it's easy, it's just a number underneath, because it's discrete, underneath each rectangle, and we label it x and p of x. So what happens to all four of those things when each random variable is increased by 1? So instead it's 4, 3, 2, 1. Well, our mean goes up by 1. And we can see it here if we literally just change it. Our mean is now 2.4. So we added 1. Our standard deviation doesn't change, because our standard deviation measures how spread apart it is. Well, it's still the same spread. It's still, we have a range of 3 here. If we changed it to add 1 on each, it's still a spread of 3. So if you go down, same standard deviation. So we have the same variance as well. What happens if we multiply all those things by 4? Well, that's different. So if we went back to our original one and then multiplied them all by 4, our mean is 5.6, which is our original mean times 4, and our standard deviation is 0.8 times 4. So when we multiply the things by 4, we multiply the standard deviation and our mean by 4. So to recap, when we add or multiply constants, just numbers, the shape doesn't change. Our center, you multiply first by whatever you're multiplying by, and you add whatever you added. Our spread, our standard deviation, is just multiplied by the absolute value. It cannot be negative, so we have to multiply by the absolute value of whatever we're multiplying by. So, for instance, if our mean was 5 and our sigma is 1.3, if we added 6 and multiplied by 3, well, to get our mean, we do 5 times 3, 15, plus 6, 21. If we want our standard deviation, we do the absolute value of 3, which is still 3, times our standard deviation, 1.3, so 3.9. If we decide to make it negative, we're multiplying by negative 3 now. It's 5 times negative 3 is negative 15, plus 6, now our mean is negative 9. We can have a negative mean, but we still do the absolute value of negative 3, which is 3, times 1.3 is 3.9. Our standard deviation doesn't change. It's still the same amount of spread out. So that's if it's one variable. If we're dealing with two independent variables that come together to become one, we have different things going on. So if we define D to be x minus y, that means all the combinations of x minus all the combinations of y. So that's 1 minus 2, 1 minus 4, 2 minus 2, 2 minus 4, 3 minus 2, and 3 minus 4. We get these values. So we get negative 3, negative 2, negative 1, 0, and 1. Those are our values that we can have. Well, we need to find the probability. Well, the way that we got a negative 3 is that we got a 1 from the x and a 4 from the y. So it's the probability of 1 times the probability of 4, because it's an and problem. So we multiply those. 0.2 times 0.3 is 0.06. And so we multiply each one each combination, 2 and 2, there's the probability of 2 and the probability of 2. 2 and 4, probability of 2 and probability of 4. Now where it gets different is we had two options, or two things that gave us negative 1. 1 minus 2 and 3 minus 4. So it becomes an and an or problem. So first we find them individually. Probability of getting a 1 and a 2 is 0.2 times 0.7, 0.14. And probably getting a 3 and then a 4 is probability of 3 times probability of 4, 0.3 times 0.3, which is 0.09. And then we add both of those up. And all of these add up to 1. So that's how we get our probability distribution. Now if we want to find the mean of this new set, it's real simple. Because D is x minus y, we just subtract. 2.1 is the mean of x, 2.6 is the mean of y. So we subtract and we get negative 0.5 is the mean of D. Now we can't do the same thing for standard deviation because we can't subtract, we'd have a negative standard deviation, we can't have negative standard deviation. And we have two sets, we add them together, they're not going to get closer together, our spread's going to get bigger because we have different sets of numbers now. So what we actually look at is the variance, the sigma squared of both of those. And we add that up. And that'll be the variance of the new set. And that's whether we add things or subtract them. So to find our mean, if we're subtracting two sets to get a new set, we just subtract our means. If we're adding two sets to get a new set, and we just add our means. Very simple. But either way, if we're adding or subtracting to get new sets, we add our variances. And we get the new variance. And then obviously to get the standard deviation, we need to take the square root. So if we look at another problem here, another example that we didn't do in class. Suppose the safe temperature for a baby's bath water is normally distributed with a mean of 34 degrees Celsius, and the standard deviation is 2 degrees Celsius. What is the mean and standard deviation in degrees Fahrenheit? This is America. We don't care about Celsius. We want to know Fahrenheit. And we want to have safe babies. We don't want to burn our babies. At least I don't. So we're going to go with that. So when we're changing this, we're multiplying and adding by constants. It's not a new set. So to get a mean of the Fahrenheit, for mean, this is like our first example, you multiply the old mean, 34, by whatever you're multiplying by, 9 over 5, and we add 32. So really, you just kind of plug it in that formula. Very straightforward, nothing confusing there. So 93.2 degrees Fahrenheit is our average bath water in Fahrenheit. Now, if we're talking about our sigma of F, well, we don't add 32. We don't want a standard deviation to be within 34 degrees. That's quite a bit. We only multiply by the absolute value of 9 over 5 and by 2. Of course, the absolute value of 9 over 5 is still 9 over 5. We don't have a negative number, but we get 3.6 degrees Fahrenheit. So this is my new mean, and this is my new standard deviation. So I didn't add the 32 there because the standard deviation would have been way too big. It did increase because we multiplied, but for standard deviation, we only multiply by the number. For mean, you multiply by the number and add the other number. So that's like our first example. Now suppose two brothers, Mario and Luigi, have a car dealership. In a typical day, the following are the probability distribution for how many cars they can sell each. Determine the probability distribution for the company from the number of cars sold per day. So our new set, we're putting two sets together, M, L, we're going to call it C for cars. So we need to find all the combinations. And there's quite a few that kind of overlap, and this is where it gets rough. We can get two different ways, or one different way. Sorry. Probability of 0 from Mario and probability of 2 from Luigi. So that's 0.1, that's 0.2, that's 0.02. So we have that distribution. To get 3, we could have gone in two different ways. 0 from Mario and 3 from Luigi, or 1 from Mario from Luigi. So we're going to multiply those two probabilities separately, then add them up. So it's 0.1 times 0.5 plus 0.25 times 0.2. And that gives us 0.1. 0.1 for 3 cars. 4 cars, we can get that by 0 and 4. Or we can get that 1, 3. Or 2 from Mario and 2 from Luigi. And those are the 3 different ways that we can get 4. We multiply those separately. So 0.1 times 0.3 plus 0.5 times 0.5 plus 0.35 times 0.2. We add all of those up to get 0.225. To get 5, you could have gotten 1 from Mario, 4 from Luigi, 2 from Mario, 3 from Luigi, or somehow Mario has a really good day, sells 3, and Luigi has 2. So there's 3 different options there as well. So we find the probabilities of each set individually, then add the 3 numbers up. So that's 0.25 times 0.3, 0.25 times 0.5, 0, missing 1, 0.3 times 0.2. And when we add all of that up, we get 0.31. For 6, we can get that 2 different ways. Probably 2 from Mario, 4 from Luigi, or 3 from both. So that would be 0.35 times 0.3, 0.3 times 0.5. You get 0.255. And the last one we can get 7 cars sold, and that's the way we can do that is if they both sell the most they can. And that's 0.3 times 0.3, so 0.09. So there is our distribution. Now the reason it was tough is because we had so many repeating, so many different ways to get 4, 5, 6, and 3. And we probably won't have that on the test, but that's our new distribution. Now, what is the mean and standard deviation of the number of cars each sell in a typical day? Well, we put that in the computer or the calculator, just like we did in the warm-up. So, mu of Mario is 5. Mario standard deviation is 3, and we square that his variance. Same for Luigi. His mean is 3.1, 0.7 is the standard deviation, 0.9. Just use the calculator or the computer the same way. Now, what is the mean and standard deviation of the number of cars a company sell in a typical day? Well, the mean of C is the mean of just both of them added up. Because C is the addition of the 2. So, they have 4.95 cars per day, almost 5 cars. So that's pretty straightforward. If we want to find the standard deviation, we have to look at the variances. Because the variance of the cars is the variance of Mario plus the variance of Luigi, which is 0.927 plus 0.49, which would be 1.417. But I want the standard deviation of C. So I take the square root of that, which turns into 1.29. That's what I'm looking for. And that's how you do this.